Okay guys, so here is another example that involves a potentiometer. So a potentiometer, as we saw, it's a component where we can have either fixed resistance across its outermost terminals, or a variable resistance between any of the outermost terminals and the terminal in the middle. And this is the potentiometer as we saw in the lab. Okay, so the question asks, if we have a battery of 36 volts connected in this arrangement to a 20 kilo ohms, then to a potentiometer, and that potentiometer is paralleled with a load of 10 kilo ohms. So when we change the potentiometer's handle to go from 0 to maximum, which is 10 kilo ohms, what are the two maximum and minimum values of V load? So to show you this sort of in images or in practice, so this is a battery of 36 volts. If we connect it to the resistance like this with a wire, and from here to the potentiometer, the middle leg of the potentiometer to this resistance, as we saw here, the middle leg to this resistance, and the second part of the resistance goes back to the battery. The same thing, the second part of the potentiometer. So this is the connection. Now what happens here, as we change this handle, we rotate it back and forth. We change this resistance here between this terminal and the middle point, and that goes from 0 to 10 kilo ohms. So at 0 resistance we have an output voltage here that can be measured, and at 10 kilovolts at 10 kilo ohms, again we have a different value of this voltage, and we need to calculate it. Okay, so this is actually a simple mathematical problem, really a simple one. So we have this 36 volts source, 20 kilo ohms. Now assume we have a maximum of the potentiometer. So there is 10 kilo ohms, 10 kilo ohms, and here is the thing. If this is 20 kilo ohms, this is 10 kilo ohms, this is 10 kilo ohms. The maximum handle was rotated to get a maximum. This gives us 36 volts as source, while V out is going to be the voltage divider of these two together in parallel, so they are 5 of this circuit. So it is 36 times 5 over the total, which is 25, those two in parallel with this guy in series, and the kilo ohms cancel each other, and we get 7.2 volts. Okay, so this is one value. On the other hand, if the potentiometer is rotated so that let me choose a different color. So if the potentiometer now is rotated on the opposite direction, whatever that direction is, so that this resistance now is 0. Okay, so what is V out in this case? So if this resistance here is 0 ohms, that means we have a load of 10 kilo ohms connected to 0, and we have whatever there is of the potentiometer and the battery. So now how much is this voltage? Well, the voltage across this resistance is 0, because this is, in this connection we have a 0 total resistance. You can prove it, or you can calculate it, and you see a 0 total resistance. That means whatever current passes through a 0 resistance gives us 0 voltage, and that's normal because this is actually the common point, and this whole thing is just a single point. So we have 0 volts and we have 7.2 volts. Those are the two values that take place as the potentiometer changes. Now, to show you this using multisim, let us choose a potentiometer. Here it is. And choose a resistor, another resistor. We need source, and we need a ground. Okay, so that's it. This resistor should be 10 kilo ohms. This resistor should be 20 kilo ohms. The potentiometer is from 0 to 10 kilo ohms, and maybe we can put it, okay, we can keep it at 50% for now. Now from here, and the voltage source is 36. So this is connected here, this guy here, this guy here, and those two guys go to the ground. Okay, now if we take a multimeter, voltmeter I mean, here it is. So if we put the potentiometer at maximum, we run the simulation, we get 7.2 volts. Now if we stop, we put the resistance at 0, we run the simulation, we get 1.2 microvolts. That's actually a 0 volt relay. Okay, I hope this helps a little bit in assuring the concepts of potentiometer and how the voltage divider with a potentiometer works. See you in a different example.